I don't like the left side, so that's the side I'm gonna play around with here. What I'm gonna do is the following. I'm gonna take this, and before I switch everything into sine and cosine, which I could do, I was thinking that we could use the Pythagorean identities. On the bottom here, 1 plus cotangent squared is cosecant squared. Oops, cotangent. And then what I was thinking about doing was taking the numerator and splitting it like this. So I'll factor it. And then, because I think I'll run out of room, I was going to put these both over that denominator. You know what I could do, though? I could write it like this. I guess probably the easiest way would be to now switch things into sine and cosine. So I'm going to have the following. I'm going to have cosine gamma over sine gamma plus 1 times cosine gamma over sine gamma again minus 1. And that's going to be 1 over sine squared gamma. So I'm going to multiply the numerator by the reciprocal of the denominator. So it's going to look like this. Cosine gamma over sine gamma plus 1 times that same thing minus 1 times sine squared. Okay, what am I going to do with that? Well, I think... What do I want it to look like? Well, I want it to only have signs in it. And it's giving me 1 minus 2 sine squared, which is the same thing as the double angle for cosine. Yeah, why not? Let's try this. Let's multiply sine squared into each one of these. So 1 sine squared into each one and see what we get. So I'm going to do, because I've got 2 of them here, right? And this is all multiplication, and multiplication is commutative. So I'm going to go like this. Cosine gamma plus sine gamma. Yeah, I think that's going to get me where I want to go. Cosine gamma minus sine gamma. And then that is going to give me cosine squared gamma minus sine squared, gamma. How far away are we? Okay, and so this is equal to, now notice I've got only sine squared up here, so I'm going to replace cosine squared with 1 minus sine squared. Okay, and there's my proof. So, you know what, I think if there was any confusion, it's probably this step with what I did. So let me, if you got the video and you understand what I did there, you can go ahead and pause it now, or stop it now. What I'm going to do is I'm going to erase some of that stuff, and I'm going to go back up to that step and make sure that if you weren't clear, you are clear. Okay, so let's erase this. Let's erase this, and all of this mess here. So what I said was, I said, okay, take cosine gamma. I'm so bad at writing the gammas. I guess there's worse things in life than being bad at writing gamma, but I don't know. I wonder if anyone's even listening to this anymore. Probably I'll already shut it off. That's right. Guess this will be for my benefits. Hey, I'm running out of room over there. So I got two signs. Now, what I'm going to do... Oh, look, my arrow already ended there, so that's nice. I'm going to go like this. I'm going to go cosine. See, don't fall into the trap of thinking you have to distribute it, because it's all multiplication. So, like, if you had the numbers, I'll do it over here in green. If you had the numbers like 5 times 2 times 3, you wouldn't distribute the 3 into both these. You would just simply either multiply the 3 by the 5 or the 3 by the 2, get an answer, and then multiply it by the remaining. So there's no distribution when you've got multiplication between terms, only when you have addition or subtraction. So what I'm going to do is I'm going to multiply. So let me kind of box them off. I'm going to do this. Okay. So I took my two signs and I put one with each of them. Now I have to distribute because there's addition or subtraction in between. So now this guy's got to go into here and into here. And that's when I get just cosine gamma plus sine gamma here for the first guy. And for the second guy, I'm going to get cosine gamma minus sine gamma, like that. And then you can proceed on with the remaining part of the argument.